Now, a related problem is the problem of having some curve, let's say f of x, it looks something like that, and a second curve g of x, which looks something like this. And the question might be, what is the area between the two curves? So this space. And let's say, hypothetically, we happen to know that they intersect here at -1, and we want to go all the way to, I don't know, here at 4. So again, the question is, what is the area between those two curves? Now, consider for a moment the two things independently and what the question would be. So let's say we've got f of x here as its graph, and again f of x, give me some artistic license here, looks something like this. And here's -1, and here's 4. And so the integral from -1 to 4 of f of x dx would give us this quantity in blue. And if we were to consider the graph of g of x independent of f of x for a moment, and it looks something like this. And again, give me some artistic liberty here because I'm just sort of sketching the curves as I go. And from -1 to 4. And the integral from -1 to 4 of g of x dx would give us, I'll use this color, this quantity here. Notice that if we were to take the entire blue area and subtract from it the area in green, what would be left is the area in red. Or just pretty it up with some colors. Blue minus green would equal the space in red. One other principle to take away from this is that the upper curve minus the lower curve equals the space between. And this is true for all cases and all orientations. So, to answer the initial question, what is the area between the two curves? The integral we would need to consider is the integral from -1 to 4 of f of x minus g of x dx. And this is irrespective of orientation, right? If g of x was below the x-axis, it would not change anything. Right. So if you want the area between two curves, there's always the upper minus the lower. Now, it does get confusing sometimes when you have a situation like this. It seems like it should be something else. Let me try and illustrate why. So here's f of x, it's above the x-axis. Here's g of x, it's below the x-axis. And we'll use our same values from -1 to 4. We want to know what is this area. And it will still be the integral from -1 to 4 of f of x minus g of x. And think about why. When we integrate f of x, we'll get this space here. And this space will be positive. This will be a positive numeric value because it's above the x-axis. And when we integrate g of x, we will get this space here. And numerically, this will be a negative value. So when we do f of x minus g of x, we will have a positive value minus a negative value, which will result in a positive sum because we're subtracting a negative. And that's why we're still getting the area between the two curves. And the same idea would be true if they were both below the x-axis. The principle is always the upper curve minus the lower curve will give you the space between.